In this episode, we'll be looking at vector quantity and scalar quantity. First of all, let us define vector quantity. Vector quantity is a type of quantity which has both magnitude and direction. An example of vector quantity we can have velocity, momentum, acceleration, force, and what? Impulse. Alright, let us also look at scalar quantity. It's a type of quantity which has only magnitude but no direction. An example is what? Speed. Alright, let us look at these examples and how we can derive some mathematical formulas from them. First of all, we have speed. Alright, and when we say speed, speed can be defined as distance per unit time. And mathematically, speed is equal to distance over time. Our distance is measured in meters and our time is measured in what? Seconds. Therefore, the unit for speed is going to be meter per seconds, or mx raised to the power -1, as we can see here. Now, from this, we can also say that distance mathematically is equal to speed times our time, all right, as we can see. And time will be equal to, that is distance over speed. So these are some mathematical formulas that we can have here. Now let us also look at velocity. Velocity is the rate of change of displacement. All right. So mathematically, velocity is equal to displacement over time. Displacement over time. Our displacement is measured in meters. Our time is measured in seconds. Therefore, the unit for velocity is also going to be meters per seconds, or mx raised to the power -1, as we can see here. All right, let us also proceed, and we can say that our displacement is equal to velocity times time taken, and also our time here will be equal to displacement over velocity. Nicely. So these are some mathematical formulas that we can have here. Let us also look at momentum. Now, when we say momentum is the product of the mass and velocity of a body. So mathematically, momentum is equal to mass times velocity. All right, and the unit for momentum is kilogram meter per seconds, as we can see. All right, from momentum we can also have another formula as momentum is equal to mass. All right, now with our velocity, we know that velocity is equal to displacement over time, so we can say momentum is equal to mass times our displacement. All right, all divided by time. So we can also have this formula here. Let us also look at acceleration. Now, when we say acceleration is the rate of change of velocity. So mathematically again, we can say acceleration is equal to change in velocity. All right, change in velocity. So change in velocity over time, as we can see here. And when we say change in velocity, it means our final velocity minus initial velocity. Therefore, acceleration will be equal to v minus u all over what? T. All right, where we can make v the subject as v equal to u plus at. Now, this is the formula for acceleration. Anytime we have been asked to find acceleration, we can use this formula to do the calculation. Also, we can make final velocity the subject, v equal to u plus what? At. And don't forget, anytime we say a body starts from rest, if the body starts from rest, our initial velocity is equal to what? 0, as we can see. Now, our acceleration is measured in meter per second squared, or we can write it m stroke x raised to the power 2, all right? And our time is measured in seconds, as we already analyzed here. Let us look at the next one, force. Now, when we say force is pull or push of a body, and mathematically force is equal to mass times acceleration. Mass times acceleration, where we can short it as force is equal to ma, all right? And our force is measured in Newton, okay, into bracket capital N, as we can see. All right, from this, acceleration will be equal to force over mass, and mass will be equal to force over what? Acceleration. And don't forget, our mass is measured in kilogram, all right, and our acceleration is measured in meter per second square, as we can see here. Let us also look at another thing called impulse. Impulse. Now, when we talk of impulse is the change in momentum of a body, and mathematically impulse is equal to force times time, all right? So we can see I equal to F times what? T. And our impulse is measured in Newton seconds. So we should be able to know this unit as well. And from here we can say that force is equal to impulse divided by time. All right. And time will also be equal to impulse divided by what? Force. So we can have these formulas here. Now, don't also forget that with conversion of unit, we can say that 1 hour, sometimes our time can be given in hours, and we can change it to what? Seconds. So 1 hour equal to 3,600 seconds. And we can also say 1 minute. 1 minute. 1 minute is equal to 60 seconds. All right. And we can also say, we can also have a conversion like 1 kilogram is equal to 1,000 gram, all right? And we can also have 1 kilometers. 1 kilometers is equal to 1,000 meters. So we can also use these conversions to convert some of our units anytime questions are being given. All right, so you go through these formulas. In our next meeting, we'll be doing calculations with them. Thank you. Try these questions on the board with the formulas that we study and put your answers in the comment section. Thank you.